to pass and have those number. Oh, we have a lot of students, they graduated.
Okay, so other people saying like LMAO, York ain't shit, should I switch schools? No, like I'm not completely roasting York. Like what I got from York was a really good sense of community and camaraderie. Like I have friends that study at U of T and like Waterloo, and they tell me like everyone is like super cutthroat. They have like no friends because everyone treats each other as like competition. Like I have made so many friends at like York, and like the community and like the people I've met have made me better as well. You know, what's the point in going to school? I mean, I'm not saying I'm not saying that like a computer science degree is useless. I'm saying in the context of LeetCode, you're not going to take a LeetCode course at York. Like you have to teach yourself how to LeetCode. But I still went to school. I still learned a lot. You know what I mean? I was actually thinking of switching to Waterloo, but no, thanks then. Okay, if you have the opportunity to switch to Waterloo, like there's its own like pros and cons. Let me see. Are you still going to take the dynamic programming course from Quran? Like, yeah, you have to take EECS 3101 to graduate. So I have to. Yeah. And someone else asked, how limited are you in using like libraries? Like, if you can just explain like, okay, I'm going to be using this like library function to like reverse a string, as long as that is not the main focus of a problem, like it's fair game, right? Like if you're doing a problem and one component of it is binary search, like that's fine. But if the focus of the problem is like implement binary search, you're obviously not going to use like a helper for that. So it's really just about like letting your interviewer know like, hey, I'm going to be using this library function. If you understand like why I'm using it, if you think it's like cheating too much, like I'll implement it myself. Yeah, you're good to go. Okay, so Anas, we're coming up on 6:40. So I'm gonna get you to like wrap up, and then we're gonna get like the next person to interview. So can you just reiterate what your solution is gonna be?
I need to run it before to make sure that it came up like I want.
You actually can't run code in this. This is just to like share code, but if you want, you can run your code in the actual LeetCode editor yourself. Like here is the problem. So if you open up that link, you can just take your solution and paste it in there, and you know.
Okay, what I'm gonna express my thought. That's the only way.
Absolutely.
What I'm trying to do is, like we said earlier, I want to make a dictionary of the 3 words, and which is the most common letters. I came out, most of them they use 3 words, but I tried to sort it by the vowels, not the vowels, the main comment, which is the TAN, the AER, and the ECD. I'm trying to make a dictionary for myself. Then every time I see how many words will match from the array itself. If I'm gonna take the EAT, it's already existed in the like eat, for example, it's already existed in the AET. Then I'll go to the next one, T, find it, which is gonna be in which one, in which dictionary, and go to the third one, do the same, and then sort it by that. This is what I'm trying to do.
No, I absolutely like understand what you're saying, and that's even my solution as well. Like that is also how I would implement this problem. So it's 6:40. So I'm gonna wrap this up. I'm gonna paste in my solution. I'm gonna talk about like line for line for everyone else in the chat who was attempting this problem. So thanks again for coming on, Anas. I'm gonna ask you to like mute yourself now. Okay. Okay, so for everyone else in the chat, this is my solution. So every time I fire up a LeetCode problem, the first thing I do is in comments, just talk about what I'm trying to solve here, right? So like I said before, there is this one property of anagrams that we get to exploit, which is that if you sort a word, you're gonna get something like this. And with this, you can actually group words that are the same, right? If I go through all the lists, if I go through all the words in this list, I can sort each of them and put it into a dictionary, and I can get a really nicely formatted dictionary that looks, you know, something like this. If I have AET, this can point to all of the words that, you know, kind of form that as well. So like 8 would be in here, eat would be in here, and T would be in here. The next sorted one would be, you know, if you take bat, if you were to sort bat, then bat would be, I believe it's ABT, and that would point to the single word of bat. And then the last group, if I were to sort nat, I'd get A, N, T, and this would point to all the words where if you were to sort it, you'd get nat and you would get tan. Now, this is a LeetCode medium problem. You should be able to solve this in like 30 to 40 minutes. I only gave Anas 20. He was actually really close to getting it right. And I know that if I give him more time, he'd be able to solve it. I'm going to critique one thing, which is that like there was just too much silence. If this was a one-on-one and like a real interview, you have to really relay everything that you're currently thinking. If there's like any awkward silence, like I have no idea what's happening in your head, and I'm going to start like deducting marks. Like you are not communicating. I have no idea what's happening. And if at the very end, you just randomly spit out the solution, like, you're silent for 20 minutes and then, okay, here's how I would solve it. I'm like, okay, but what is all the steps you took to finally arrive at like the right solution? You know what I mean? If this was for me, I would say, okay, so to begin, there's an property about anagrams we can exploit. We can group things together by sorting. We just to keep things nice, we could use like a dictionary. At the end, we could loop through the dictionary and return everything. Like from start to finish, how did you get to the final solution? So that's definitely what I would recommend. Silence is never a good thing. Now, I'm done my bit. I think we have the next person we're going to interview, which is
Keandre, I think.
Keandre, and Jason, I'm going to let you take this one then.
Cool. Sounds good.
Can you guys hear me?
Yep.
I'm so nervous, bro. Oh my God.
Oh, don't worry.
Okay, just send me the
Sure.
send me the code share link. Oh my gosh.
Okay, can you guys see my screen?
Oh boy, I'm already scared.
Share. Just do your best. I think ultimately, you'll never be able to know whether or not you'll be able to solve a problem.
Hold on. Is this? And I was surrounded by water. Hold on. This looks like Conway's Game of Life, no?
I'm
Is
not
this
too
it?
sure.
Hold on. Now is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may see one from the other surrounded by water. Okay, I'll just give it a shot.
All right, so the link's posted in the chat. I'm going to give you guys about, Chris, you said 25 minutes for the previous session?
I'm going to give about 20 minutes just because we only have until 8 and I want to get through like a lot of questions. So
Cool. Sounds good. So we'll go up to 7:03.
You posted the code share link in the chat. I don't know if you meant to do that.
it's fine. No one else just edit the thing. So Keandre and Jason, it's just you two, and we'll start now.
Okay.
Okay. So is this? Are we starting now?
Yep. You can go ahead.
Okay. Given an mxn, I don't know what does that mean? An mxn 2D.
So an m times n, right? So like the rows would be m, and the n would be the columns.
M times n. Okay, my bad.
Mm-hmm.
Given an m times n 2D binary grid, which represents which represents a map of ones, islands, and zeros, water, return the number of islands. Okay. An island is surrounded by water and is formed by connecting adjacent lands. Okay, an island is formed and connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are all surrounded by water. Also, assume that all four edges are surrounded by water. Let's see here. So, for the edges, wouldn't that mean the very corners? What does it mean by that?
So you can basically assume that outside of this matrix we see here is just all zeros. So you don't need to account for any other ones surrounding this matrix.
Okay, so it's just the matrix.
Mm-hmm.
So an island is surrounded by, is a form by connected by adjacent lands horizontally or vertically. Okay, so let me look at this first example first. So basically, what I'm doing now is I want to make sure I truly understand the problem before going through any solutions. So I'm just looking through it to make sure I know the wind conditions so that I can actually, so let me take a look at this. So input grid. So if we look at this over here, so we have 1, 1, 1, 1, 1, 1, 1, 1, 1. Okay, so it's one island. All these ones are connected to each other. So that's one island. And then for this input grid, 1, 1, 1, 1, and then we have 1 and then 1, 1. It's a 3 islands. Okay, the problem makes sense. Okay. All right, the problem makes sense. So now that I understand the problem, it's a class solution, right? Let me think about this. So, okay, this is going to be this is a difficult problem for me anyway. So I'm looking here, and if I go through the array like sequentially, like let's take a look at this one, right? What I see is I see that this one is connected to this one. So this one over here, this one is connected to the one down to the right. And then this one's connected to the one to the bottom, right? I
So
see that.
I'm going to give you a quick clarification. So keep in mind the question is mentioning that it's horizontally or vertically. So just now you mentioned that it goes diagonally. So keep that in mind. You're just going to be looking from the right and below, or up and to the left.
Okay. I see. Okay, hold on. I mean, I think I do. I think this is easy money. I think I got this. I think I know what to do. I think. So if okay, I don't know. But if it's just diagonally and vertically, right? So I see that let's take this for example. If we were to go to the right, then we go to the right again, and then we go to the right again, and then we go down. That would be, and then we go down here, down here. So what you're doing is you're checking, basically you're going through, whoa, okay. This problem is going to be so complicated. Oh my God. I don't know. So I see I think I see what's going on. So if you look at this, for example, right over here, this one is connected to the one to the right. This one's connected to the one to the bottom. And then after you check the one here as well, so it ends at the water, but you also check the one down here too. And then after these would be like it's ending because there's water here, vertically and horizontally. This would be kind of where it ends, right? And then after you'd start over here. So you see if you see at this one, if you look up and then you look at the bottom, you'll see that and you look to the left and the right, so horizontally and vertically, you'll see that it's a lone island by itself and it's surrounded by water. And then if you look over here, I think I have a better feel for the problem now. Oh, I see. I think I have a better feel for the problem. All right. Okay, I have 10 minutes left. I don't think I'll solve this, but I think I'll get kind of close. So
That's all right. Just try and go as much as you can.
So my initial intuition. So my initial oh, somebody. Sorry. I thought I got a message from someone. So my initial intuition is to. Let me think about this.
So let me know if you need a hint at any point.
Wait, if you've got a hint, I'm gonna take it right now.
Yeah, for sure. Yeah, so you know, I'm not sure if you've taken 2011 or 3101 yet, but there's just like you mentioned earlier, you know, you're going to be exploring all the ones to the left, to the right, and below, right? So we're going to be doing some sort of search, right? So there's typically two patterns that you see a lot of. One of them could be a depth first or a breadth first.
Okay, I have not taken 2011, but you just gave me a useful hint because I'm like vaguely familiar with search algorithm, very, very, very vaguely. So I think there's something grilling at the back of my mind. I'm gonna share it with you. Okay, so I take a look at this, right? I take a look at this. You see it selected, right? I take a look at this first line.
Yeah.
Okay, and I'm noticing something. Thank you so much for that search hint. Okay, I'm noticing something, right?
Sure.
So I see that all of these have a 1, right? And then I see that these 3 also have a 1. So I don't care about this 5th part. That's you see what I mean?
Okay.
And then after over here, I also see these 2 ones over here.
Mhm.
So what I'm searching for, so to speak, is like I'm searching for where there are ones. So if you look at over here, there's 2 here, and then there's 2 here.
So hold
And
on a
then
sec. So I'm gonna pause you right there. You mentioned something about searching for the ones. Now let me ask you a question. So let's say you have a 1 and a 0, right, in this matrix. Okay.
okay,
That would mean that for us to actually find out whether or not it's a 1, we would need to search all the zeros as well as the ones, right?
that's true. Yes.
Mhm. So think about that first. So how would we kind of search through all the ones and zeros in this matrix?
Okay. Well, you'd have to use a nested for loop, of course, because it's a 2D array, right? But I
Nice.
mean,
Okay. So that's part of what you're trying to accomplish here, right?
yeah, of course.
Mhm.
So okay. So I'm getting closer to the solution. I can feel it. I can feel it.
Mhm.
I can feel it. Okay. So, all right. So let's say hypothetically, I search through this grid, right?
Mhm.
Then I search to see if anything in the first 4 is a 1, and I get a match, right?
Mhm.
And I get these 3. And then now that I know that, I have to search for these 2 to see if I get 1.
Mhm. So
So if that means so if that happens,
mhm.
then then um if that happens, then they're all connected. But then if you look over here, look, if you'll see those 2 1s, so only these 2 are relevant. Actually, yeah, so only these 2 are relevant. And
Mhm.
then after, I think I and then after if you look in the third one, because there's 2 zeros here, that doesn't matter, but then there's a
Mhm.
1 here, so you would search for a 1 here, and there's not a 1 there, but there's 2 1s there. Oh, I think I'm getting, yo, I think I get it. I think I get it. Am I getting closer? I think I got it. I think I got it. Yo, did I Jimmy Neutron this? Did I big brain this? I think I got it.
So write down, right? So if you've got like a somewhat of a like a pseudocode almost, try writing it down in comments down here. It'd be easy for you to
Okay.
keep track when you start coding it up.
Okay, I'm gonna have a little comment here to basically explain everything I'm doing. Search, so search for I'd say like search for ones. Okay. Search for ones, see if it continues on the next line. This is very poorly worded, but like I don't have an exact solution. I
Mhm.
hope you can understand this. So search for ones and then see if it continues on. Let's say see if it continues on the next line. If it continues, then it's all a part of one island. But if the index is disconnected, then the island ends, and you search for more islands, I guess.
Mhm. Yep, that sounds
Okay.
like you're on the right track. So keep going, see what you got.
Okay. So, um, okay, but these are the. So I understand the problem, but these are only given these 2 solutions. So what I'm gonna do is this is gonna be kind of weird for you. I don't know if I do this at interviews or not, but I'm actually gonna create my own test case so that because creating my own test cases, it'll allow me to like spot like kind of like logical errors. You know what I mean? So I'm just gonna create like my own randomized test case, kind of. So that'll be 2 islands. That'll be yeah. So now that I see there's a flaw. I can't just search for ones because if there's a zero in the middle, then these
Mhm.
are 2 different separate islands.
Mhm.
So if I do 1, oh man, this problem is complicated. Christ. Okay. So now what I'll have to do, Jesus. Okay, so the problem is
So
more complicated.
I'm going to give you another hint that might help out when you do find the ones, right? So let's say you're iterating through the rows and columns in this matrix, okay? And then
Okay.
you find a 1. So I remember you mentioned earlier that you're going to batch the ones together, but let's just say we found a 1 here. What's your next step? What's the next step you're going to do after you found this 1?
Oh, I think I see. I think I see it. I forgot what the algorithm is called. It's like this, isn't it like a searching algorithm, like A star? I think. I think that's what you do. I think you keep on searching, or you could use recursion, couldn't you? So you would go, you would look at. Like I know the general concepts, but I just can't. Oh, this is so frustrating. I know the
So
general concept, but I just okay. Sorry, I'm sorry for interrupting you. Go ahead. Sorry.
that's all right. That's all right. So I'll give you kind of help clarify the general concept if you haven't worked with it too much before. So essentially what you can do is, let's say you found a 1 here, right? So this question says that it connects either horizontally or vertically. So that means you can either go down or you can go to the right, right? And then once you move on to this one, well, what are we going to do here? We can either look to the right and below. So we're going to look to the right. We found there's no 0. Okay. And then the next thing we're going to do is we're going to look below. We found a 1, right? Okay. And then what we're going to do is now we have 3 nodes, right? So we have 1, 2, 3. So we're going to search a 0. Well, that's not a 1. We're going to search another 0. That's not a 1 either. And then we're going to search to the left. Now, the reason why we can't search this one again is because it's been visited. We've already been there, right? So we already know what's there, right? So we're going to move on to the 1 to the next, right? Now, all you have, because we visited this one, all you have is this value, right? So we're going to search that one, and it's not a 1. So that means that we have 1 island. So what are we going to do after that?
Well, now that you have 1 island, you would store the positions of all of those and then search for the next one, right? And then do the same thing over again.
Well, remember, keep in mind what you're trying to return, right? You're just trying to return 1 counter that's keeping track of the number of islands. So you don't necessarily need to store these as individual islands, but you would need to store their positions, right?
Yeah. So you would store their positions to make sure that you don't go back to the same position before, right? And then once you do all the searches and you finally encounter a 0, and then you add 1 to the counter, and then after you search for the next one, do the same thing, and etc.
So I'm just going to give you a time heads up. You've got 5 minutes left. All right. Don't worry, try your best. Keep working through it. Keep working through it. Get as far as you can, right?
Okay. All right. So you have a good point. So what you do is I would search this one, then I would go to the right, and then I would go to the right, and then after, okay, question. In interviews like this, so typically in like LeetCode problems, because I've done a couple, it's usually only 1 function. Am I limited by just that, or can I solve the problem any way I want as long as it within the class solution?
I've had interviews where you can like create your own helper classes. If it's a recursive, solution, you can create like an object in another function. So it's really up to you. It's whatever you want to do. As long as you're explaining your thought process during the solution, then that's all that really matters.
I see. Okay. Okay. So let's see. 3 minutes left. Okay. All right. Let's see what I can do. I'm gonna write some code down. I'm gonna do it. Okay. So what I'm gonna do is, I can have like a. Okay, no, but that would just be the function itself. Okay. Because recursion, you have to like, call the same thing back again, right? And kind of like, because like I've done like maze solving algorithms before. Okay, let me think about this. So go here, you go to the right, and then you stop there. So you'd have to call itself. So maybe search, and then I get it now. So what you would do, so basically you have the function. So let's just call it, what do you want to call it? Amount of islands or something. Pretty explicit, right? Then then you're given a list of, because it's list a string, right? I'm just gonna pass it for now. So what we want to do is you want to have a search algorithm, right? Using the string. I mean, it doesn't have to be outside. It's not cleaner that way. So a string, right? So what we can do is and then we can give it maybe an X position and a Y position. This is probably not the most efficient way to do this. I'm inexperienced, but so I'm thinking what you would do is you would say for what's the Python function? It's like zip, and then after you can get the so I'll just say for Y in range. Oh wait, I forgot to give it a. Am I stupid? Okay, I forgot to give it a. I'll just call it map, and then that's going to be a list of strings. There we go. That's better. So for X in range, and then in Python, I think it's just the length of like map 0, I believe. Then we could say for X in range, the length of map 1, if I remember correctly. Oh man. Oh, thank God you didn't put any like time complexities or I'd be screwed.
All right. So you know what? I'll stop you right there. That was good. You know, you got okay. So I've got a couple things I just wanted to comment on. I don't know if you want to see the solution first or you hear about your critiques first.
I want to hear both, so it doesn't matter to me.
Okay. So you know what? Let's go through the critiques first. I thought it was really great that you tried, you know, really working through the problem, right? One of the first things that you really want to let the interviewer know is that, well, even for yourself, that you understand the question, right? So what you did was you went through, you know, okay, well, I have a grid. This is why I have an output of 1. You know, this is how I could potentially move through it. And then you asked me a really great clarification question is, well, what does this mean, right? What does this part of the question mean? And you can only kind of figure that out if you run through one of the examples, right? So I thought that was really great. Clarification, no, there's that. So another thing to kind of keep in mind is that when you're actually working with this example, you kind of briefly batched it together, right? But you want to go one by one, right? You want to think in the smallest thing. What's the first step that I'm going to do? What's the first step that I can actually? Now, the first step is, well, there needs to be some way for me to move this through each one of the cells in this matrix, right? That's already one mark right there, right? That's already part of the solution. You know what I mean? So you could write that down here. Well, okay. Just like Chris did earlier in his example for his solution. Well, I need to walk through the matrix, right? And that'll be really important for both you to see later on as you're trying to figure out the solution problem, as well as the interviewer to see what this guy doing? What is he, you know, trying to go through, right? The second thing is another way to kind of break down this problem, because it is a complicated question, right? Is you want to see, you know, there's 2 cases. The first case is if you're at a 1, the second case if you're at a, right? So if you're at a 1, what am I going to do? You should be asking yourself these questions, right? Just like I kind of hinted to you earlier, if you're at a 1, well, I'm going to search to the right for another 1 in case there's a connected island, or I'm going to search below if there's another connected island, right? So, okay. In our pseudocode here, if we see 1, right, I'm going to run some sort of search. You know, you really have to know right off the bat. You can kind of figure it out through the question, right? I'm going to run some sort of search to find all connected islands. Okay, so see how I'm kind of working through this step by step on the smallest possible level, right? So what happens if we get a 0? If we see 0, right, we're not really going to do anything, right? We're just gonna mark as visited, right? So I'll talk a little bit about that after. Mark it as visited, and then keep searching, right? Now, at this point, you know, you kind of think, well, how am I going to ensure that every node or every cell in this matrix that I visited already, that I'm not gonna, right? Because just like equation is just like breaking down a problem into smaller problems, right? So if you check the same one again, you're going to do that infinitely until it just basically doesn't work anymore, right? So we need some way to keep these cells marked as visited, right? So look at all these points that I'm doing. This is exactly what I'm going to code up step by step. And it also kind of helps me flesh out, you know, your thinking as well, right? Now, the 5th thing is that we're going to do is, okay, well, I'm going to increment the counter, right? Because that's what we're trying to return, right? So you always want to kind of talk of right? So what am I trying? I'm right? So we're going to increment the counter. There, that's the solution right there. In a lot of cases, I've had interviews where it was like a really easy question and they saw these lines and they're like, all right, well, we'll just move on to another harder question. But by then, you've already got one question down. Okay, so I'm going to post up solution.
Yeah, I want to see it.
Down here. So this is, how I guess I would approach this question. The beauty of this question for everybody kind of trying it themselves is that there are two ways to approach it, right? You can either do a depth first search or a breadth first search, right? So in this case, I've done a breadth first search, which is that searching function you were talking about before, right? So I have my, my method of keeping the rows and cells visited as marked, right? I'm going to just add it to the set, okay? I have a way to iterate through all the values in the matrix, okay? And to answer one of your questions is, well, can I use a helper function? Yeah, of course. I've got one defined right in the middle of my function, right? Which is the BFS, which is actually going to do the search, right? Here.
Question.
Sure.
I've never seen the set function before in Python. Is that like a mathematical set from set theory where there can't be any duplicates?
So
is it like that?
When you go through data structures and algorithms, they'll teach you, about sets. And sets is basically like you can't have any duplicates, right? So this avoids any possibilities of, let's say, for some reason in your code, you happen to revisit another cell. This set will only keep non-duplicates within it. I see that, sorry, I can't see your name there, but I see that you've got your hand up. What's your question?
Kind of. I don't know if it's like yours, but like, can I just really quickly go through it if that's okay?
Yeah, for sure.
Okay, so first of all, you would have to like define the parameters. So when you're on my method relies on like searching again for all the surrounding values. And so again, you have to define the parameters. So if it's 1, right, your x, if your x value is 1, then of course you can't go right horizontally. And if your y value is 1, then you also can't like go vertically up, or if it's at n, wait, it's m by n, or is it n by m?
It's m by n.
It's m by n, and so you can't. The n is the maximum value. So if it's at n, you can't like look down.
Sure.
So you define those specific parameters, and then from that point on, start at the first row, and you basically look for surrounding land, or if the actual you look if the block is land, and once you find a block that is land, you look at the surrounding ones, and basically you count up an island. So you basically have a for loop that reiterates itself, and it just keeps on searching for more lands, and until it's identified the entire thing, it just adds it like you basically search, you examine if there's any land, like, actually, no, sorry. For the first one, you don't actually need to do that. For the first one, if there's like block of land, that's it, you have an island. And then once you move on to the other rows, you can actually look up, right? And if you find any block of land, if there's land above it, you can essentially just say that this has already been counted, right? If there's land above it, that means that it was counted in the previous thing. So you skip past it, and then you keep on doing that. And would that work technically?
That kind of sounds like the searching approaches where you're looking up, left, right, and down, and then you're incrementing like a counter to keep track of all the islands. And that's kind of, that's essentially the solution you should be working towards. Now, it's a little bit tough to visualize explaining it out loud, but if I were to see it in code and kind of go through all the test cases, then that sounds about right. Yeah.
All right.
The rough idea of it. Yeah.
All right. Thank you.
Yep. So I'll just quickly show you guys. This is the DFS approach, pretty much the same as BFS, except for you're doing it recursively, where you're just like you said earlier, you're going to be incrementing up, left, down, right, and below. So Chris,
Thank you so
pass
much.
it off to you. Yep, no problem.
Right.
Great.
So
I'm definitely doing another one if I can.
the next one that we have is Hassan. So Hassan, you want to unmute yourself and I will take control of the screen share again. So here we go. And here we go. So let me just get, oh shit. Let me see here. So this is the new, okay, well, that's the freaking solution that I had. That's not cool. This is the new problem that we'll be working with. Hassan, you here?
Yeah, I'm here.
Okay, great. So I already sent you a link to the code share.
Yeah.
So are you in here? Are you able to type?
Yeah, I think so. Let me just double check.
Okay. Yes, you can type. Okay, and I'm going to assume that you're doing this in Python as well.
I'll try C# because I'm
C
not
sharp.
proficient with Python.
Okay, so C#, and you are good to go. So, so this problem is top k frequent elements. What I've given you is like an array of numbers, and I want you to return to me the k most frequent elements, right? So in the first example, I give you 1, 1, 1, 2, 2, 3, and I want you to return to me the top 2 most frequent elements. So you have a 1 3 times, you have a 2 2 times, and a 3 1 time. So the 2 most frequent elements is 1 and 2. So, you know, I gave you 2 examples. If you have any clarifying questions, feel free to ask me, but otherwise it's all you now.
All right. I haven't done any of these problems in so long.
It's all right. So just tell me what you're currently thinking of. Like, try not to keep the silence. You always gotta tell me like what's happening right now.
They are in an array, right?
Yeah, it's in an array.
And so all of these they're all integers, right?
Yep, all integers.
So I'm guessing like there should be a count. So like let's just say if like how many ones are in the array, it should be something like that.
Yep.
And then like we'll have to calculate like the max. So okay, like let's just say count is the number of counts of the integer. So like let's just say count equals to 3 for the ones.
Okay.
And count equals to 2 for number 2 and all of that stuff. So we'll have to calculate the max count for like for that respective number. And
I don't think I'm actually understanding what your solution is. So what kind of data structure are you thinking of like using to solve this?
actually haven't thought about that.
Okay. So you're right. I mean, like you will have to take account of all elements you have. Like you said, you have 3 1s, you have 2 2s, you have 1 3.
Yeah.
So the first thing is like, how can you even store that? And the second way is like, how can you do it efficiently? Right?
Yeah. I'm not gonna lie, I actually don't know.
Okay. Would you like me to just jump into how I would approach something like this?
Sure.
Okay.
Just before you start, I just have a question before you start
Yeah,
answering.
sure. Go ahead,
That
Arnaud.
could be resolved by using the linear search or not.
Can you do it in linear time? I don't think you can do it in linear time. You can get pretty close with n log n, but in linear time, I actually don't think so.
No. Okay.
So if I were to do this, I'm going to switch back to Python. Quick select. Oh my God. Quick select is too advanced. Even I don't know quick select, but let's see if I switch it back to Python. Okay. So let's see here. Joffrey, initialize a hash map to the nums putting blah, pull into array and return the array. Okay, so actually, you actually got pretty close, Joffrey. I hope I'm pronouncing your name correct. But the reason I chose to do this problem was because in all the problems that we were working through today, none of them mention using a heap. Now, I wanted to introduce a heap problem because a heap is like a special form of tree that I actually don't see very often in problems. So the problem is asking having the top k most frequent elements. Now, to me, when I think of like top k of something, I think of using a heap, right? Because you could use a max heap to continuously get like the max frequency of some element, and you could use a min heap to get like the least frequent element. So if this problem was a phrase, you could use like a min heap. But the property that we want to use is obviously a max heap, right? Like the most frequent element is what we're trying to look for. So def, oh shit. So def func, we're going to take in an array of numbers and we're going to take in some k. So yes, we want to use a map, right? So I'm going to say numbers is equal to a dictionary. And what I'm going to do is say, so for each number, for num in, okay, I'll make this nums to be more Python friendly. So for each number in the numbers array, I'm going to say, you know, if num not in numbers, then numbers of that num is now equal to 0. Actually, you know what? Why don't I just do this on the LeetCode platform itself, top k frequent? So then I can even run it against test cases. So, and if my keyboard's really loud, please let me know because I know my keyboard is loud. I have blue switches. So, okay, so let's start. So numbers is equal to an empty dictionary. So for num and nums, what I'm going to do is say numbers of that num will be equal to 0. Okay, so after that, numbers of that num plus equal 1. Now, what that right there does, it puts all my numbers into a really nice dictionary. So I'm going to print it up right now. So if I just run the code, we can see that down here. Okay, what the hell? For num and nums, numbers of that num plus equal 1. How do I have 0 1s, 2 0s, and 3 1s? Standard input is what the hell? Numbers of that num plus equal 1. That's weird. What the hell? How am I getting 1 3? Oh, right. What am I doing? If num not in numbers. Holy shit. Wow. If that was an interview, I already failed it. Okay, so for num and nums, if the num isn't in the numbers, set it to 0, otherwise increment it, and then do this. So at the end of running this for loop, we are going to have 3 1s, we have 2 2s, and we have 1 3, which is great, right? That's a really good way of knowing we have this many instances of this number. Now, what we also want to do is also put this into a max heap. So what I can do now is say, actually, would it be easier if I just pulled up my solution and I explain it this way? Okay, I'll have this up here so anyone can do it in their own pace. So do this, get rid of that. So if anyone does not care to hear my explanation and you just want to know how it works, I'll just leave it up here, but otherwise I'll be typing it again here. So after we make this frequency, we need to put it into a heap because our max heap will be the best way to know what is currently at the top of our tree. And if you don't know what a heap is, I actually really recommend you learn how to use it. So what I'm going to do now is say for each key in our numbers, I guess kind of dictionary, what I'm going to do is say we need a heap now. So heap is equal to, I believe it's this. If you don't know Python, then the syntax is going to look like really weird, but this is just how you would use a heap in Python. So for each key in my numbers dictionary, I'm going to push it into my heap. And there actually is no max heap in Python. It's a min heap by default, but there's a really great way you can get around this. But if you make every number negative, it effectively becomes a max heap. So, oh, I think I heard someone talk, but
Oh no,
numbers of key multiply by -1 and put in that. So this is going to be a tuple. Actually, yes, it is going to be a tuple. We're going to use a tuple here. Oh, I screwed up. There we go. So why are we using a tuple? Because we're trying to put in the frequency and the value it's at. So like I said, we have 3 instances of 1. And our next tuple would be 2 instances of 2. And our next one would be 1 instance of 3. So it's going to go into our heap. And what's going to be at the top is the 3, of course. The way heaps work is it's just going to pair by the first key in a tuple. So that makes it really nice to know.
one question, what's a tuple?
A tuple is like an array of some elements, but here's a really great question that I actually got in an interview once. Why can you not use like an array as a key in a dictionary. It's because it's mutable. But you can use a tuple as a key because tuples are immutable. So that's why I'm going to be using a tuple instead of an array for my heap here. Well, I mean, I guess you could use arrays, but I just really like using tuples. So, so now for each instance of k, we're trying to get like the top k elements. So I'm going to get my return array here. So, you know, result is equal to an empty array for I in the range of k. So I'm going to iterate to the number times the k. So if k is 2, then we're going to go over it 2 times. And I'm going to say result dot append. And we're going to pop from our heap. Actually, it'd probably be better if I didn't do it in line. So we're going to say like element is equal to heap pop of the heap. And it's not just the heap, because if I were to print it, remember we made it a tuple. So if I were to print each element, I would get something like this. So what we really want is the first element, which is this 1 here and then the 2 here, because we're not trying to get the frequency, we're trying to get to the actual number itself. So now I'm going to put that in my result, dot append element, and then return result at the end, and that should do that. And if I submit it, then you are good to go.
All right.
Okay. So memes to the max, layers of bless, was all in a different way. Okay. I would use a dictionary, but I wouldn't use heap. So Keandre, why would you not use a heap? Because you can solve this out a heap for sure, but it wouldn't be the best complexity, right?
I just want to use heaps because I don't know how to use it. That's why.
Okay, yeah, see, that's actually, okay, I'm going to talk about 2 bottlenecks here. The first one is the bottleneck of this problem is what is the best way of getting the max number quickly? And if you just had it in an array, you'd have a loop every time to find the next max, right? Well, if you have a heap, then you know that the max value is always at the top. And the second bottleneck when you're just learning how to do LeetCode is, I don't know how to use a heap, so I'm going to use a completely different solution, which is going to get you like in more trouble than not. Refusing to learn something new is probably not how you're going to pass your interviews. Like, you know, the way that I learned a heap was actually this question right here. Like, because of this question, I taught myself what a heap was. So if you don't know what a heap is, try attempting this problem. Learn how to use a heap in your language of choice. But yeah, that's pretty much it for this problem. It's 7:30, so I actually am going to like hop off. Sorry to like be hanging, Jason.
Let's go, Chris.
Okay.
I'll
Let's
be ending
see.
soon.
Okay, I actually just have a question from Sarah I'm going to answer quickly. Does knowing Java versus Python matter for LeetCode questions? Yeah, and you know what? I'm actually really glad you asked that, because I'm going to screen share again, and I'm going to explain exactly why I will always recommend Python for interviews. So let me even just open up Python 3 on my compiler. So if you ask me, how do you make an array list in Java? Okay, I'm pretty sure, and it's been a long time to use Java, but isn't it something like list of what? Is it integer? Array list is equal to new array list of type integer, something like that, right? That's how you want to make an array list in Java. Okay, if you want to make an array list in Python, it's literally this. This is the only character you have to type if you want to have an array list in Python. I know this is really important because in a 45-minute coding interview where you're like really cracking to like crank out a solution and you're under pressure and everything, the less you have to type something like this, the more time you have to actually think about something. And there are just so many like really great things you could do in Python. Like if you have a string, like string is equal to A, B, C, D, E, F, G, H, I, J, K, you can literally loop over this so easily. So for index character in enumerate string, you can do a lot of really quick hand things like print, you know, index char. I don't know how you do this in Java. I know it'd be a lot more lines, but you can literally get a really nice tuple of like the index something is at and the actual letter respectively. And there's just like so many more examples, but I hate Java because it's so much typing for no reason. Oh, and also another great thing, this syntax here, this syntax I have highlighted right here, an array in Python is an array, it's a stack, it's a queue. I'm pretty sure it's also a heap. So this here represents 4 different data structures, and you would just use the appropriate operations. So that also makes like this very flexible. Yeah, the moment I switch from using Java to Python, like I passed like way more interviews. So I'm gonna keep saying like Python like all the way. Okay, with that being said, I'm gonna let Jason take control of the room. I am out. It was great talking to everyone. Cool.
All right. Yeah, so we've got a little bit of time left. I'm gonna leave it up to the room, and you guys can message in the chat, but would you guys want to continue running through some more questions? Do you guys want to do another mock interview? I saw somebody wanted to do like a list of people who wanted to do a mock interview. I could run through a question myself, or we can even ask some questions and answers in terms of internships or finding internships and things like that. Yeah, Karen Preet, you've got a question?
I'd personally prefer to just like do one question with like a medium difficulty and just have all of us try it, and
Yeah,
whoever solves it wins bragging rights. Yeah.
sounds
Sorry.
cool. Is everybody good with that?
Yeah, I'm good with it. Yeah,
Yeah.
I want to do it. Can I
Sure. Yeah. You know what? So I'll send everybody the question. I'll give you guys 20 minutes again, 20 minutes, and then we'll take it up at the end of the 20 minutes. So this
All right.
is the question. Hopefully that's not premium listed. No, it's not. Okay. So we'll stop the time at 7:47. Yeah, 7:47.
You're having us do the binary tree zigzag level order transversal.
Yep. So I'll give you guys some time to work through it for a little bit, and then we'll take it up.
All right, thank you.
Yep.
Just to verify, it starts at left to right and then continues that way?
For the question?
Yes.
Yeah. Yeah.
Okay, thank you. We don't actually have to use a node, right? I mean, like the tree node. We don't actually have to like make a binary tree. We can just use the input that's used to make the binary tree and then straight up get the output from that, right?
Yeah, but you'll be manipulating each node based on the input, if that makes any sense.
Wait, so we have to use a tree?
Like the tree is just like a construct, but what is actually given, I think, is just the root node. So you need to do some way to like traverse that tree using that node, right? So if you're given like, if in that picture you're given like the top of the tree,
Yeah.
which is like a node, so you got to move through
Exactly. It's
those
just-
nodes, right?
Instead
Which
of
means
actually
you'll be
having to make
manipulating
the tree and
the
then
node, yeah.
transversing it through that, can't I just have an algorithm which kind of does it for me? Like divides up the actual roots into.
Yeah, well, yeah, there's definitely two algorithms that you can use to solve that problem, but I can't let you know which ones.
Exactly. Okay, thank you.
Okay, I have a question.
Yeah, what's up?
I don't really understand the problem. Okay, so if you look at the function, you're given a root, and it says first off, what's optional? I forgot what that was in Python 3. What is that?
Optional?
Yeah, if you look at the function definition, if you look at in the parameters,
Oh, object?
No, optional, all that means is that the tree
Oh.
node can be none. It's basically
Oh.
just a nullable. Like it might be a tree node, it might be none.
Okay, yeah. So you're just given a tree node, so you can put in that object, right? And it returns a list of a list of integers, right? Wait, is my understanding correct thus far? You input a tree node, and then after you return a list of integers, right?
Yeah.
But
Yeah.
if you look in the first example, it says root is equal to 3, 9, 20, null, 15, 7.
Yeah, so
which
that's
is
just
not a
no, but like how this tree is represented is in a, like I guess in this case it would be a root node pointing to this array, right? So the root node would essentially be like 3 at the top, and then you need to somehow traverse this tree in order to get and like take each value from each node so that you can add it to like a list, if that makes any sense.
Please repeat that.
Yeah, so when you're passing the root node, think about it like you're being passed like 3, right? Now, the children of 3 are 9 and 20. So you can essentially go to the left or the right using that definition of a tree node. And that's how you'll add all those values into a list, right? So try and think about it
I see.
As the picture defines it, right?
Okay, I see. Thanks.
So also to clarify, for LeetCode, basically the input spec that is shown is a lot of times in, if you're given a tree, it will be shown in terms of an array. But basically what LeetCode does is it will actually parse this array of integers, make it into a tree, convert it into like tree node objects, and then give you the root of the tree. But if you go down into the bottom right and there's like, if you run code, there's like a run code result. The tab to the left of that is a test case. It will actually show you the raw test case in array form. And to the very right, there's a toggle that's a tree visualizer. And you can basically play around with the array and see how LeetCode transforms it into a tree for you. So it's nicer than just dealing with raw indices, but that's how the test case is written. So it actually makes a tree for you, but you can interact with the raw test cases if you want to do so.
Wait, how do we view the actual like example test case? Because I need to determine if it's actually putting in the roots as a list or if it's actually making a tree for you using the class function.
It's just follow the type definitions. You're given the tree node, and at least in Python, it gives you the definition for the class.
Wait, could you repeat that? Sorry.
So you're in the, I can't see your screen, but if you're using Python, on the right side of it, in the comments, there's a class tree node. Yeah, and basically, if you want to get the value, it's whatever your node, let's say root.val is going to be the value, root.left is going to be its left child, which could be none or could be another tree node. And same goes for the right child.
All right. I'm having trouble finding the actual comments thing that you're talking about. I don't know where it is. You talking about like the compile?
If you want to copy all your code, and then in the very top right, there's like an arrow saying there's like 5 buttons in the top right. One of them is an arrow.
Default code definition.
Yeah, if you reset it, copy your code first. But if you reset it, you should be able to see the original comments.
Confirm. And that just resets it to the base state. Are you?
Yeah, but in the base there should be.
Oh, you're talking about the comments. Okay.
Yeah.
I thought there was like a comment tab, and okay. Never mind. No. Sorry. All right. Thank you.
Yep. And now, see if you got a question.
Yeah, Jason, for the efficiency of the code, is that better in the interviews or not? Like how speed the code will be?
For sure. Yeah. So like let me think of it, give you an example. So you could take like a Fibonacci question, right? So
Mhm.
Fibonacci, there's two ways you can approach it. You can either use like the basic recursion that you learn in class, or you can take like a dynamic programming approach to that kind of question. And in those scenarios, the complexity would be like highly different, right? So the dynamic programming approach to that question would be like a lot quicker. And essentially in interviews, they're looking for the fastest code. You know, of course, communication is very important. But if you don't have an optimized solution, so like let's say you're doing something in brute force, they'll ask you, you know, is there any way you can improve this? Is there any way you can make it faster?
They will then, the meaning they're gonna tell you if they can, if they know the code could be faster, or could be like execute faster, and they will tell you that to change it.
Pretty much, yeah, yeah.
Mhm.
That can that can be solved by a lot of like the common like these interview questions. They all follow like a kind of like a common algorithmic pattern, and you can use those like 2 pointers or sliding window to make the program faster.
Okay, I understand that.
Yeah.
Thanks, man.
So I'll give you guys 5 more minutes just so we have time for any questions at the end of this session. So you guys have until 7:45 if you're still working through it.
Am I allowed to make another function, just like get the height of the actual thing?
Yeah, you could, but in this case, it wouldn't necessarily be needed. But I'm sure you can do whatever you need to do.
Okay, well, now I'm not going to do it. Thank you.
All right, guys, we're coming up in 7:45, so let's go through this question. Okay, so this is how I would approach this question. I don't know if you guys saw in the chat, but I don't know, can you guys see my screen? Yep, okay. So this would be a level order traversal or a breadth first search. And essentially the first thing we'd probably do is most likely check if the root is null, right? If the root is null, there's no nodes that we can add to our final result. So we're going to return an empty result. Then I've initialized a deck, right? So maybe I'll annotate this as well to make it a little bit easier to check. Okay. And we have a deck. Okay. Now a deck, double-ended queue, so we can add, take off from one side, we can add, take off from the other side as well, right? Okay, so essentially what I'm doing is I'm going to be searching each level of this tree. And then using a flag, our left to right here, will essentially change that to true or false. And that'll dictate whether or not, which side we're going to be adding to our list, right? So an example of that, so to explain the use of this deck is basically going to keep track of the amount of nodes that we'll be searching through at each level. So we'll add this to the deck, we'll add this to the deck, we'll add this to the deck, we'll add this to the deck. And as we're popping off of this deck, we'll use the flag to determine whether or not we're popping off from this side and putting it into our queue, right? Or popping off from this side, putting it into our queue. And that would dictate whether or not it'll be left to right. And here's the pseudocode that I would code up to basically describe what I just explained. Does anybody have any questions? Does that make sense? Is it clear?
Wait, could you repeat the popping off to like the other, okay, so popping off from the left. Yeah, popping off from the left. Could you explain that really quickly?
Yeah, so for us to kind of have the current node that we're trying to explore, right? So the current node that we're trying to explore is going to be the first value that we popped off. So if it's this one, right, we're going to check if there's any left to right children. Okay. Level.append. Yeah. Oh, sorry. So if we're going to be popping off from the deck from the left, right, this will be the first node that we pushed onto this deck. Okay. If our flag says, left to right is true, then we're going to be adding the value to the left side. Okay. If our value is false, then we're going to be adding it to our right side. Okay. And essentially what we're doing is once we've added to either the left or the right side of this deck/queue, then we'll convert this into a list and return that as the result. So I was mistaken earlier. I said this was a queue when it's actually a deck. All right. Does that make sense? Cool.
Just slight thing. So there's no possible way of like working backwards, right? Starting at the top, just because of the one thing that I asked earlier. You mentioned that it had to start off from left to right. And you could only really do that if you had, I believe it's an odd, wait. Yeah, I forgot what I calculated, but like, yeah, you could only do that if the length of your binary tree was like even or odd, right? And so
hold on, let me stop you right there. Well, what do you mean by the length of the binary tree was even or odd?
Like the number of so it's height, sorry, not length.
Sure, okay. But
yeah, and so not I don't know if it's odd or even, I forgot, but like one of the two, right? It had to either be even or odd in order for you to be able to work backwards. So you to be able to go from the top node, right?
Mm-hmm.
And then go either right to left or left to right.
Mm-hmm.
And that way you could work backwards. So you would start off with the last element of your list and then keep on adding elements to the start. Like you go transverse through it and then.
I think so. Instead of kind of manipulating how we're adding it to our final list, you're kind of manipulating whether or not we're searching from the right to left node and then left to right node. To answer your question, So when I initially tried that question, I was kind of thinking the similar approach, right?
Mhm.
Like, well, if I know how to do a breadth first search, then why not just search from right to left? The issue with that was that, well, one of them is it's definitely harder for you to kind of keep track of how you're going to be searching through this, right? Instead of just kind of manipulating and creating like a deck for you to store these elements. The second issue, I remember I ran into an issue where I think it was that I couldn't really get the right to left to work, right? So what would happen was that if I would be adding elements to like the right of a queue or right of a deck, then it wouldn't accurately search like the left half, right? When I'm trying to flip it back, if that makes any sense.
Yeah, that
Um,
makes sense, of course.
But for sure, yeah, you could definitely try and explore that, and that would definitely reduce the amount of space you use. But I think personally, if you're going to do this during an interview, it would be easier for you to just create that deck, 2 decks, right? One to kind of keep track of the current level you're on, one to use as your like result, and that would be a lot easier to keep track of as well as explain, right?
Personally, like the approach to actually code shouldn't take more than like 20 minutes because
Mhm.
all you have to do is first of all just define the thing, and then you have to basically just do a similar thing to what you're proposing, but it's less complicated. So
For sure,
but
yeah.
it's space complexity. So
Mhm. Yeah.
yeah. All right, thank you.
Yeah, no problem. Does anybody have any questions about internships or preparing for internships? I don't know if you guys have any other things you wanted to ask. Yep, sure, go ahead.
Yeah, I have one. Okay, so I'm not taking fundamentals of data structures
Mhm.
or does I think next semester.
Yeah.
But I'm still interested in like doing LeetCode problems. Do you
For sure.
think that's possible? Like, do you think I could actually gain real progress without that knowledge?
Yeah, so a great resource that I've used, it costs a little bit of money, but a great resource I've used is called Grokking the Coding Interview. This will basically break down, the different pattern algorithms that you might see in a coding interview. This will also kind of briefly explain the data structures and algorithms and how to use them. It'll give you a bunch of questions related to that subset of algorithms. Excuse me. And then you can start off by using that and kind of looking up things as you go along, making sure you understand everything. Excuse me, sorry. And that would be a good approach for you to start doing LeetCode.
I see. All right. Thanks. Thank you so much.
For sure. Yeah. Could you suggest what sort of projects to work on and what tech stack should be used there to improve resume? What sort of projects? Guys, like a lot of people ask, like, what kind of projects will get me a job? And at the end of the day, as long as you have a good project that, it doesn't really matter what tech stack you work on. But as long as you have like a good project or, even a simple project, right, on your resume, that's all that matters. I know when I first started my my internship outside of Lassonde, I didn't know how to use Python, and then I learned Python on the job, right? So just have some sort of project on your resume. Do we need a project? What if we don't have any? Well, not everybody needs projects. I find, if you have internship experience, it would definitely help a lot. Hackathons are a great place to, if you don't have any projects, that would be a good place to kind of add that experience to your list as well. Yeah, but you need some sort of thing to kind of fill up your resume. Yep. What's your next question? Somebody raise your hand.
Oh, so I had a question about, wait, what was my question on? Sorry. Yeah. Sorry, 1 second. I just completely.
Yep. Take your
forgot my
time. Take your time.
Oh yeah. So do we actually like have to like attach our GitHub to our resume or something? Is that how it works? Because they have like no proof of actual, like I'm assuming they require like a proof of projects, right?
For sure. Yeah. Well, in my personal experience, I'm sure attaching your GitHub it's not going to be detrimental to you, right? Like it's not going to, when you do add it, it's not going to be bad for you, right? But in my experience during interviews, everybody kind of asks me more detailed questions about what I worked on, what challenges I faced, things like that. Of course, some companies might check your GitHub and go through your projects, but as long as you have you can talk about your previous experience with the project, then that would be really important. Probably the most important thing, I think.
Okay, because it's just like I've done like a lot of hackathons and all that, but like
Yeah.
I've never actually like uploaded them onto GitHub or anything. So
For sure, yeah. I mean, if you want to upload them, that would definitely help. But if you can talk about like those hackathons and what problems you face and what you did, and talk about like what you used and how you used it, that would be really important.
all right, thank you.
Yeah. Yep. Anas, what's your question?
Can you name some resource that's really gonna be useful for us, like an online resource, for example, like to improve the skills, like for the data structure or the way of thinking, the programming thinking?
For sure, yeah. So I think grokking the coding interview, I texted that in the chat earlier, but I'll leave it in the chat again. Grokking the coding interview, that again, that goes through all of the basic, algorithms or data structures that you might encounter in a interview setting. I've actually got a list here of all the different topics. So what I kind of do is I study the topic on grokking, and then I try and do as many questions until I have that pattern down. Another really good thing you can use is if you've got like some friends you want to kind of compete with, binarysearch.io. That's really fun because you can have like a room and you can set the difficulty of the questions you want to do, get some people together, and you can kind of compete against them. I see Jordan's one of the participants, and we kind of ran like a quick fun one at night one time, and that was really great. Another thing that I would recommend would be LeetCode. So of course you can go on YouTube and you can like look up, solutions, but I find that LeetCode kind of shows you diagrams of how and what's going on, with his LeetCode solutions. So those are really great resources as well. But I would highly recommend doing grokking. If you can't buy it or you don't want to buy it, there's always the PDF online you can download,
Okay, this is what I really need, like.
I hope
something
that
like
answers
neat.
your question.
Yeah, this is exactly, so the neat code is the most, I want to use before. And it's actually help you to understand the problem, not just finding the solution, understand how the solution came, like to the reality.
Exactly, yeah. And that's really the most important thing, right? Because you can do a bunch of questions, you could check the solutions and like review that. But if you don't know, like I remember in my Amazon final interview, I've been practicing like graph questions on LeetCode. And then the interviewer gave me one where he made it up. Like he made up a graph question that I had never done. And if I didn't know like how to use it, yeah, it was pretty rough. But I got through it, so yeah, just make sure you understand all your stuff.
Yeah, you're not cheating and stuff. Thanks.
Exactly, yeah, for sure. Counter?
Yeah, I'm looking for. I don't see the PDF. Can you link it possibly if you have it or no?
I could definitely search around. If you join CSHub Discord, I think I can. Let me see if I can interview or send a link. But in the resources channel, I can probably post that. Jordan,
send a link, please.
do you have the link to that Discord?
Yeah, I put a link in the chat, invite.gg/CSHub.
Dope.
And that goes
Gotcha.
through Discord server.
Mm-hmm.
I think it's on GitHub. I think I found it. If that the one you're talking about.
Yeah. And then somebody asked, where do I sign up? Sorry?
Oh, sorry. Are you talking about, is it GitHub? Is it the one with the folders with the Python files?
Yeah, I think Anas sent it, yeah.
Yeah, I think this is the one.
Mm-hmm.
Oh, okay. So it's just solutions. It's not actually the course. I see.
Mm-hmm.
Or like a book. I see. So what do you do? So it kind of like so it gives you a section where you can try the question, and then it'll show you the solution below it, and it'll kind of talk through like what's going on in the solution. And all the questions, like all the topics, they're related to stuff that you would see in an interview. You know what I mean? So it's just kind of like a course with some questions associated with it, but it's really helpful. I see. So would I be able to like if there's some concept in there like heaps, do they explain that so that I would be able to Google it?
Yeah, I think there's a section. I think that's one of my next ones. 2 heaps. Yeah. Also, if you really don't understand, you can always look it up as well, right? As you're doing the course, right? Like you can look up like, oh, how do I use a heap, or what are some functions I can do with heaps, right? So the next question I got was, how many interviews did you have to do for Amazon? So for Amazon, it was the first OA, which is basically they send you 2 coding questions you have to do in 45 minutes. The second one was a work simulation where It's basically like they give you questions about things that happen at work and you have to respond to them. There's no LeetCode in that one, but that one was probably the hardest because it's so ambiguous. The third one was the final interview, 45 minutes, 15 minutes for like the question. And then he only gave me like 25 minutes. So I don't really know. I think we just went over time for that. And yeah. Where do I sign up to get events and updates about events like this? The binary search IO stuff, that's just something you can like set up yourself with like a couple people. But if you join the CSHub Discord, Jeffrey, you should be able to see sometimes we post like a link for binary search where you can just join in if you want, and then you can just participate. Yeah.
Sorry to interrupt. Are you guys done, or like, do you guys need more time?
Does anybody else have any questions? Any questions? Probably like 5 more minutes, Fayez. Like 3 more minutes, I guess.
All right, sure. Yeah, sure thing. Just take your time. Just Jordan, can you just at me on Discord and let me know when it's over?
Yeah, for sure. Yeah, and I join. Make sure you join our CSHub Discord. As I typed in the chat, we're gonna post. I think we're gonna post these links that we just did onto the resources channel that we have on our server. So you guys can go check that out there if you guys miss it here.
Okay, anybody else have any questions? We're all good.
Jason, in the beginning, I think Chris mentioned something about coding club, if I'm not mistaken.
Yeah, so the CSHub, plug our Discord. The CSHub is a great place. As far as coding competitions right now, we don't have any organized. You can also check out, I believe, LeetCode. LeetCode has contests every weekend where you can join in and you can actually like, it's like a timed question, right? So you can do one every weekend in LeetCode. You can also go on, I think Code Forces, I'll type it in the chat, Code Forces. That's another thing. It's more competitive programming, but there's contests for that as well. And as for like the York clubs, I'm sure LES and CSHub are going to host more of these events. But if you want to train for these events, the LeetCode contest is a really great way to kind of sharpen up your skills. Even if they're hard, even if you can't do it, if you're working through it, it'll be great.
Yeah, that's increasing your speed.
Exactly, yeah. Somebody asked for my LinkedIn, so I'll send my LinkedIn. You guys can post your LinkedIns in the chat as well.
And just to add about like just like practicing coding like with a group of people, like just like if you're in like CSHub server or something like that, or like get a bunch of friends together, you can just have a casual like night where you like post a link to what's that website, binarysearch.io, and then you can just get together just anytime you want to just code together or compete against each other, stuff like that. Just yeah,
for sure. Anybody else have any questions? Oh, yeah, Keandre, go ahead. My bad.
Okay.
Yeah.
All right. During first year, I did a York engineering competition, and for programming, and I won second place. So,
oh, nice.
Is that the type of stuff the type of stuff you're talking about? I could put that on my CV and my resume.
Oh, big time, big time. Yeah, if you add that to your resume that you like came second or you placed in one of these like events, that'll help a lot, right? That'll help a lot. Yeah.
Do I have to like? Okay, so I can just put that then, right? Okay.
Yeah, you can just add like maybe add if you guys want. I think on my LinkedIn, I'm gonna see if I can post my resume. So follow up, and then you can like add it with like a subtitle, the date, and all that kind of stuff.
Do you have that? Because I need the date and stuff. I don't remember it. Like I have a picture of one slide. That's it. I should have saved all that stuff.
I think if you look it up, you should be able to find it. But just like include like you won this, and then like what you did, maybe like 2 points or something like that. And that would be good.
All right.
Yeah.
All right. Thanks.
For sure.
Okay. I don't see anybody else. I don't see anybody else asking questions. So I mean, I'm gonna capitalize on this.
For sure. Yeah.
So, I actually do have some projects done, and I'm interested in what you think of them. So I'm gonna put my website in the description. So
I think
just take a quick. I don't need you to just take a quick overview and just like give me your first impressions, like because like interviewers, people who like and do the interview process, they're not going to spend. HR is not going to spend long, right?
for sure.
So
Yeah.
I just
Okay, so add me up on LinkedIn. I think the time is about up. So I'll message you on LinkedIn and then I'll give you my feedback. How about that?
oh yeah, for sure. Okay, what's your LinkedIn? Your LinkedIn is
So it's in the chat.
Jason. Let me see it. Jason Yang.
Yep.
All right,
Hates,
I'll
yep.
Yeah, I'll sign in and I'll message. I'll direct message you.
Cool. Sounds good.
Okay,
All right,
this
guys.
was so great. Thank you so much for everything.
For sure. Really appreciate you guys coming out, eh?
Thank you, guys. We appreciate everything. It was a great night. Have a good night,
Thanks.
guys.
Bye, guys.
Ciao.